Welcome, it's time for Metrics Uploaded, and of course we'll be dealing with science. You see me, you know it's science coming on. This is TK welcoming you, and yes, you can see today I am a real teacher, and I hope and believe that today you will cease calling me TK. You'll be actually saying sir, because you can see I really look like the teacher there. Today it's lesson number 22, and we're talking about charge quantization and capacitance. And of course, as we always do, we're taking it from grade 10 to 12. So stay there and watch and learn. Make sure you have your pen and your book and you're writing and you're learning with me as we get this lesson unfolded. Now, let's start. Charge quantization. What do we mean by that? Now, we are saying here that the charge on an electron is known as an elementary charge. In other words, that charge on an electron has to remain like that. If we have one electron, that electron will carry that charge. So the charge is quantized. It has to be exactly what it is. It cannot be more, it cannot be less, as long as we're talking about that one electron. Now, if we're talking about two, it will mean that you have got twice the charge of an electron, where the number of electrons actually will be telling us how much charge can we be talking about there. Either that charge is transferred to another object or that charge is received by another object. Remember, it's electrons that are always in motion. The positive charges, the protons, are always stationary. Okay, now this elementary charge on an electron is found experimentally to be 1.6 by 10 to minus 19 coulombs. And of course, if we want to be precise enough, we can say that this charge is a negative charge because we're talking about an electron is negatively charged. So this also means that if we're talking about a proton, P, a proton will then be carrying a quantized charge of plus 1.6 by 10 to the power minus 19 coulombs. Why do I say this? Remember that if I've got one proton and one electron together, then I've got a neutral charge for that substance. But once I have one electron gone or received, then I've got a charge carried by that substance. If the electron has been removed from this neutral charge, then the charge gains a positive charge. And how big will that charge be will depend on how many electrons have been lost. If one electron has just been lost, it means that object will carry that charge. If two electrons have been lost, it means that that object will carry twice this charge. That's what it means. Okay. Now, this quantity of charge lost or gain when electrons are lost or received by substances. Okay, so this quantity, that what we're talking about, this quantity, it is the charge that is either lost or gained. Okay, knowing that it is electrons that move. Okay, the number of electrons received or lost will determine the total charge lost or received by a substance. What we mean by this? It means if I've got n number of electrons that have been lost, the total charge that I would have, so this is n number of electrons. So charge total, okay, will be equal to number of electrons times 1.6 by 10 to the power minus 6. And to be consistent, let me put a negative there because we're talking about an electron which is negative. Okay, now total amount of charge Q, just what I have shown, will then be given by N times the charge on an electron, where N represents the number of electrons gained or lost. Let's look at an example here. Two small identical conducting spheres carrying charges of plus 2 microcoulombs and minus 6 microcoulombs respectively are suspended on long silk threads and are free to move. The two spheres touched each other and separate afterwards. Calculate the charge on each sphere after they have separated. Now look, from the previous lesson we know that the resulting charge will be given by, on each sphere will be given by charge on sphere 1, plus charge on spheres 2 divided by 2 because they were 2. And then we'll say we've got plus 2 microcoulomb plus minus 6 microcoulombs. You divide that by 2. And this will give you, this is going to end up as minus 4 microcoulombs divided by 2. What we have is minus 2 microcoulomb. Now, this is minus 2 times 10 to the power minus 6 coulombs. Remember microcoulombs, when you convert to coulombs, you need to multiply by 10 to minus 6. Okay, now so that is the charge on each sphere. Now here, calculate the number of electrons transferred when the spheres got into contact. What you need to do, we can look at sphere 1 and check on how the difference in charge happened. It started from plus 2 microcoulombs to what? To minus 2 microcoulombs. Now, when you separate that and you divide by the charge on an electron, you get the number of electrons that were transferred. See you in the next section.